eyes here.
In every cell of our body, with the exception of the red blood cells, we have thousands of mitochondria. They're tiny little bodies. And the interesting thing about them is that they contain a very tiny piece of their own DNA. It's actually because 1.5 billion years ago, they were actually a free living organism of their own that's become incorporated into our cells many, many years ago. So they still have this little bit of DNA. Their main job in the cell is to produce energy.
Lining them up, but there's nothing there particularly to do anything with.
Particularly things like loss of vision or hearing, muscle weakness. You can get neurological issues and diseases affecting the liver, kidney, and heart. It often results in early death. In fact, sometimes the death can even come in infancy. What you do is you remove the donor's genetic material from that egg. So it's kind of an empty egg, really. It's containing mitochondria and other things, but no genetic material from the donor as such. And then you transfer your patient's genetic material, her chromosomes, into that egg. So now you have her DNA, but in a healthy egg that doesn't have these affected mitochondria.
They're kind of frozen still.
Typically, we see that less than 1% of the total mitochondria have come along with the mother's genetic material. That shouldn't be a cause of concern. The only issue is that it has been noted that occasionally you can get a sudden explosion in the population of these mitochondria that have been transferred with the genetic material. So that means that although the egg begins with a very low number of potentially defective mitochondria, that number could potentially increase. Those studies have tended to either have little or no follow-up, or the reporting of them has been rather opaque. And so we don't know too much about them in most cases, at least where this has been done to avoid a mitochondrial disorder. So we know of a handful of cases worldwide. As far as we know, everything has been okay with those cases, but there's very little information. In a way, that's one of the nice things about the fact that this is being done under license and with very tight regulation within the UK. We know that when the results are fully shared publicly, they're going to be very detailed, and we really will get a much better understanding of whether this technique is working perfectly well, or whether there are some deficiencies in it or some problems. The egg provides all the resources, the energy, the proteins, and everything that embryo will need for the first 2 or 3 days. If the egg is not really good enough, then the embryos simply never develop, or they develop for a day or two and then stop. And we do see some infertile patients where every time they have an IVF cycle, for example, they always fail to produce embryos that develop. So for them, the suspicion is that this is probably going to be related to their eggs. And so there has been the suggestion that you could use a process like this to move the patient's genetic material into an egg that is more capable of sustaining embryo development.